for Computer Integrated Manufacturing. Course code BTM3514. Okay, lecturer is Muhammad Asraf bin Muhammad Asman. Okay, so for our group's member, TB21051, Muhammad HAKIEM bin ISMAIL, TB21064, IRFAN ALIMI HAIKAL bin Muhammad ZAIN, TB21052, HAIKAL bin MARZUKY. Okay, for question number 1, a unit load ASRS for work in process storage in the factory must be designed to store 1,000 pallet loads with an allowance of no less than 20% additional storage compartment for peak periods and flexibility. The unit load pallet dimension are depth X for 38 cm and width Y estimate for 52 cm. Okay, maximum height of a unit load 46 cm. It has been determined that the ASRS will consist of 2 isolate with 1 SR determined that machine per isolate. The maximum ceiling height or interior of the building permitted by local ordinance is 25 meters, so the ASRS must fit within the height limitation. The rack structure will be built 20 cm above floor level, and the clearance between the rack structure and the ceiling of the building must be at least 20 cm. Okay, we go to for the next calculation. Okay, so we want to find the dimension, the rack structure, height, length, and width. We must evaluate first, or we must take first the total capacity. Okay, the total capacity, as we can see in the table, 1,000 pallet. So the number of isolate is 2, X, Y, Z, and ABC is the same in the question, is the same. So 380 mm, 520, 460, and A 150, B 200, and C 250. Height from floor 200 mm, space between rack and roof is 200 mm. Okay, so for the total number of storage and total, we use the 1,000 pallet. Okay, 1,000 pallet. Okay, number of storage compartment per isolate. Okay, so per isolate, we use the pallet for 1,200. We divide by 2, so we get 600 per isolate. Okay, and then number of compartment inside of the isolate. The isolate, one of the compartment, we divide by 2, so 600 divided by 2 is 300 per isolate. So our allowance value A 150, B 200, and C 250. Okay. So for the height and Z, we use Z plus C. Okay, as you can see, Z, X, Y, Z. Okay, we use Z plus C. And Z 560 plus 250. So we get the height and Z, we multiply with 710 mm. So we got H total. Okay. So for height, we use NZ multiply by 710 and 24,600 mm. Okay, next. Okay, for the width, we the equation we must multiply by 3 multiplied by x plus a. So 3 multiplied by 380 plus 150. So we get 1590. So we divide by 1000, we get 1.59 meter per isolate. Okay, so the width we got 3180. So we divide by 1000, we get 3.81 meter. So as we can see for the length, NY multiplied by NZ and 300. Okay, so we get for length we get 5760 millimeter, and we divide by 1000, we get 5.76 meter. Okay, so that's all. We can continue with IRFAN and HAKIEM after this. Okay, thank you.
Assalamualaikum. My name is IRFAN ALIMI HAIKAL bin Muhammad ZAIN, and I will answer the question of 2A, 2B and 2C. Okay, for 2A, to determine the SR transaction that can be completed in 1 hour, first of all, we need to identify the TCS, and this is the formula that I get, and I get 8.62 min per cycle. And after that, we need to find the TCD, which is the formula is almost same at the top, and I get 13.2 minutes per second. And after that, we just do this, and I put in the formula, and lastly I got 16.4988 transaction per hour. Okay, this rate that I highlight is the final answer. Okay, for 2B, the utilization of air during peak hours can be calculated as, okay, for this I just make like this, and I get peak hour is 91%. Okay, this is for 2C that I have made I made it's myself, and this is my circuit for answer 2C, and let's run. Let's see what's happened for the output. Okay, this is my 2D. As you can see, they take the pallet into the pallet rack from the trailer. Okay, we see for 3D. Okay, we use window 3D. Okay, this is my 3D. As you can see, the pallet rack, I use the height 24.6 meter as like answer in number 1 at the project. Okay, as you can see clearly. Okay, next I will show the detail of my build. Okay, so my pallet rack use level of height 24.6, like the answer of the question 1. Okay, that's it for simulation for the question 2C. Okay, next Hakim will conduct for question 3. Thank you.
Okay, so for the number 3, we have select this component to be manufactured. Okay, so we have 3 steps, which is number 1 is roughing, number 2 is sweeping, and number 3 is curve following. Okay, so for the first step, for the part operation, roughing, we need to elaborate this component. So roughing, for the first column, the radial, we set the diameter of 50 and the axial 0.5 millimeter. And for the second column, we select rough stock and also part, which is rough stock have been selected here, and the part, also the part body, to create the component inside this component. Okay, so for the number 3 is the tools. We have set the diameter of 10, and the machining have set to 2000 millimeter. And for the number 2 is sweeping. So for the sweeping, the axial is set to number of level 1 and maximum depth of 1 millimeter. So for the column number 2, we select part and check, which is what is check. Check is the tool ball is not touch this area, so it will operate in this component only. So for the fourth column, also we set to the 2000 millimeter for the machining. Okay, so for the number 3 is curve following. Now we have 9 separate curve following, which is because we have 9 line in here. So for the every curve following, we have set the line, which is for example, for the curve following line, we need to line number 1, which is the name is line 8 here. Sorry, for the curve following 16, because this is the last part of the curve following, we should make a line inside of this component. The line can see if we show the part body and rough stop, but now we cannot see. So if we create line 8 until 13 inside this 1, 2, 3, 4, 5, 6, 7, 8, the line should be smoothly aligned. So I will show the operation. Yes, this is the toolbar. This is the roughing step. And this is the sweeping. And this is the curve following. So if we can see here, the curve following is very nice for the last line, because we have set the line for the every curve following. So this is our number 3 project. So the total machining time in this project is 10 minutes. Okay, so that's all from me. Thank you.